This is going to be a pretty simple talk about building reactor at big scale. So just to get started, hello, I'm Josh. I'm a software engineer at Canva. I'm from Adelaide with my partner, and my two cat rats, Nix and Six, that you can see in the corner. I don't post very frequently, but I'm on common platforms, my LinkedIn, my GitHub, or like you can find other contact details on my website. So there are three big compliant obstacles to React code maintainability. Big ones are essentially state management with many disparate consumers, prop drilling derived refactoring overhead, and code comprehension difficulty, and components of external service dependencies. So as you expect, this makes it really hard to work with other people because we'll either end up stepping on each other's toes, or you end up with bugs caused by a bunch of side effects, code that needlessly pushes things down the tree rather than keeping the state shallow. This is mitigatable. So reactive states. Redux use reducer as mostly Redux. So big learnings from Redux is mutable state prevents a lot of bizarre errors, allows state rehydration and snapshots. So that's super duper advantageous for a rich internet application like Canva. So you can undo, redo document states, and you can also do state diffing for reliability. Actions that apply to your state should be pure functions. So given the same input, you should add it against that state, should produce a state output, same state output at a particular time. As a bit of background for Canva in particular, our stack uses MobX, functional reactive programming library, which consists of observers and observables, actions, computer values, and derives. My personal favorite state management library is Adelaide, which is kind of like Redux, with a lot of nice stuff on top. It makes it more granular, prevents a bunch of crazy state validations, and means you don't have to pass context everywhere. So just quickly, these are sample stores, super duper simple. These store states. And I'd like you to think of state as essentially an initial value and actions as a mutator that applies a function against the, sort of like the state mod in Haskell, if you guys know how that works. So it's essentially applying that action function on top in order to make it look like the state is mutated, and then applying that down. So the original state's mutable, but it's effectively changed. So it's more apparent in Adelaide. So actions are inline, got your store there, you set states, and you override that state. What isn't shown there is Adelaide by default. If you only provide an individual key, it will actually spread the original state. So it'll create a copy of that original state. So that way you can create a new version, which then becomes the new state. So this isn't to say that local state is completely horrible. The reason that local state should still be used is if you're still doing like live components, like say you've got something simple like an input, so like a text field, that's still going to have some internal state. There's no real way around it. You don't want to be delegating that that form value up until you need to actually fire an action. If your component type is sufficiently complex that you've got multiple components, you should not use this state. You should be essentially containing that in the highest points and then trying to keep all those components lateral. So that brings me to mitigating prop drilling. Just as like a little here. All of these do relate to each other, and that will be very apparent by step 3 effectively. So mitigating prop drilling. Prop drilling is a problem Reacts where you're passing one particular property from a component upstream to its children many components deep. It's not particularly harmful if you're working on small projects or if it's like 1 or 2 components. But if it's like 6 or 7, at that point it becomes very hard to know where the concrete property is. It can also cause massive problems with refactoring whenever you have to modify it with the code. So that's why we intentionally try to keep our tree as shallow as possible. So how we do that is we prefer composition over drilling. So if you pass in a React component as a property, instead, as I've kind of demonstrated here, so say we've got our store and our dispatch here. These are just generic, it doesn't actually map to anything like MobX or anything. You've got this particular observer here. And I will essentially add a button if there's a profile enabled. And then it will fire an action if there is like a logout event or something like that. And the reason we do that here is otherwise you would have to have like on logout or on click, and then you would have to pass that up with a bunch of handler props. So you would end up with this being a few layers deep. And also your navigation would have to know the implementation details of the header. We also have to manage that state itself. So not particularly like.
So store and dispatch are like arguments to this function?
Not an argument actually. So what you'll notice is this is returning an observer which creates a component with no props. So this is a constructed component that is essentially puts that store and that dispatch into a closure. So at that point,
they just closed over basically.
Yeah. So then you don't have to worry about passing that state deep throughout the reaction, and it doesn't need as many implementation details. So as you can see, we're taking in a header component, which would be, for example, this would return. And yeah, the menu doesn't have anything, which is ideal.
And are they sort of usable or not, I guess? Because store and dispatch sounds like.
So store is, so this is an observable, sorry, an observer. So it looks at the dependencies for that store. So this is kind of equivalent to what we do in Moments.
Okay.
So we look for, say this would be a observable. So I remember how we had an observable box here. It would be effectively creating a dependency graph for this particular object and then validating when that particular value is changed.
Okay.
So essentially you would just need to know where create header is, and then you would be able to define that concrete sort of state where it's being created. Or just seeing where it's being passed in. So then we go on to dependencies. Dependencies are where it gets wacky, because dependencies are also fixed. So if you're building a rigid application, anything sufficiently large, you're going to have a bunch of systems that you have to depend on. We want to do this in a testable manner, so we want to have fakes, mocks, etc. we can substitute in. Our stores typically are the major view dependency with only the view. So with only like the store, you'd be able to render that particular React component. We want to keep our actions pure, although our services are not. So we have to do something in order to be able to trigger that service code from the UI without causing that that sort of impurity to leak into actions. So this brings in a rather old sort of model, essentially backwards and preventers. So Factory in this case would configure dependencies, so I would allow for the whole plugin in a box. So realistically, this here is an equivalent of a factory in this particular case. So we would have, for example, say we have document service. We would pass in our constructed version of document service here, or a baked variant if we want to do testing. But we wouldn't pass it directly into what's rendering our component. So what we would do is we have a program which takes all of that potential side effect L, and only when it's able to safely provide the inputs that is guaranteed to provide that state with a fixed input that is predictable, is when we take states. So the presenter uses those dependencies that we've especially configured. It fires actions to mutate our customers. And actually runs the drivers from the actual so the component is configured by that particular state that is stored in that store. And it of course sends all of those handlers to that presenter. So the benefits of this is we have predictable state properties, cross-swappable behaviors, easy testing, easy refactors. We also have the ability to send those actions that get fired over a network to keep multiple versions of the document model in sync. That's what we do. We also have the ability to essentially create a history tree where we can change the document state, take snapshots, and stuff like that. Super duper easy and saves me all the hell refactoring. I think probably the best example I've seen is at the first company I worked for, I was doing React. We had an on-click, hand-on-click component that went about 11 layers deep, which I don't need to tell you is really, really hard to follow. I had no idea what the concrete behavior was. It took me about 2 hours to find it. The colors they were using a state container model as well. It's weird. But it also makes it super easy to test. We have a bunch of tests that we can configure and log any particular state of the application. We can also provide values to populate and store, and that way it's possible to see any particular state of value by runtime, which is really great when it comes to what is it called, snapshot testing and integration tests. So if you're interested in working on cool things, I've got to shield my benefactors. Canva is a pretty great place to work. We do cool things and we write fun design software. So feel free to have a look. Any questions?
I have one question. So when you have these all these closures now, is there a risk that you kind of can't clean up stuff? Like there's all these references which are kind of existing still, and so you're doing stuff that's been garbage collected? So Modex actually does really great job of unmelting all these thoughts from the Understanding reference. Okay. So it's like a combination of JavaScript reference count and Modex being smart and actually clean up. It's pretty reliable actually. Any other questions? Is this Modex used very widely?
It is nowadays. When I was first place I used it at, it wasn't super popular back then. But it's more typically used in enterprise. because it allows people who don't really care about a mutable state to generate things that will effectively allow you to have a mutable state. So it prevents you from creating that. That's why I'm more of a fan of Sustand, because it's more transparent about what it's doing. And it doesn't hide that sort of reactive framework. Yeah.
Similar question I got asked. Would you say is the benefit of the functional side of it? Is it just the purity of those functions, or do you actually have like some composition things you can do, like you build a button based on some properties that?
Oh, you absolutely can. I was just essentially skating over that. You can have like all of these pipelines. So you can actually have streams as well. There's a lot of other functional reactive constructs that exist within MobX. Just to go over them. With Zusley in particular, it's pretty bare bones, but it also works outside of React. So it allows you to sync things that normally you would have to use a bunch of use effects, a bunch of external references, and essentially have the overhead of the React tree with like this external code that will be hampered by the React tree. But with this, you could actually have it stay in sync with React without having to be within React. Cool, right? I hate this game.
All right. Oh,
What's
sorry.
your sort of heuristic for when you stay?
I think if you're starting to have issues where you're having very obvious state management bugs, so if you're having essentially, if you're having to do like all of these callbacks to keep things synced, and if you're getting errors from essentially trying to do action management with queue states, then you should be reaching for something better. Not necessarily something as heavy duty as MobX or Redux, but I think a lot of people would be quite happy with React now has a use reducer, and you could use React context. But if you're starting to have issues where that's not common enough, that's when you pull out stuff like MobX because it becomes super granular. The benefit of MobX and Zusley is that they will only re-render the part of the tree that is like completely necessary, whereas use context and use reducer is not enough, which is it will re-render that entire tree up until where the reducer is mounted, so which is not great. And thank you.
Thank you.
For listening.